Here's my work, my notebook.
Oh, thank you, Michael.
It includes every problem in there.
I'll try to get that back to you next class, okay? Actually, second, let me just look. Okay, you can keep this. You might need that for studying.
Thank you, Professor.
Okay, okay. Now, excuse me. Here's the attendance sheet. Can you add a date to that, Michael? The first on the top of the row.
Thanks.
Let me begin with a word of prayer before I forget. Dear Father, we thank you for this day. I thank you for these students. Just ask you to help us use this time wisely, just to glorify you what we do. To wrap up any questions we might still have about the test, which is upcoming, Lord. In your name I pray, Lord Jesus. Amen. All right.
You are the attendance sheet.
So, yeah.
Did we go over problem 31?
There has been a request for 24C and 25C. I will add 31 to the docket. So, let me mark these down so I don't forget them. Okay. We will get to it though. All right. So 24C, 25C, 31.
You go over 21 as well.
21, maybe, if we get to it. Let's see here. Come on. You gotta give me a second here. I gotta look it up. I do not have the problems memorized. It would be all right. So let's see here. 24C, I think, was first person asked me that one. Yes, 24C. Let's talk about that one. So you're supposed to find you're looking at x squared plus bx plus c equals to 0. Your goal is to find real values for b and c so that this equation has the solution. What do you want the solution to be? What? 2 plus root 3? And what else?
2 minus square root 3.
All right. So the way to solve this is, if we want that to be the solution, that means that this has to be able to be factored to x minus 2 minus the square root of 3 times x minus 2 plus the square root of 3. That's the factor theorem. The factor theorem says that the quadratic equation has a solution only if it can be factored in that way, right? So then you figure out what b and c is. You just multiply this out. So that's like, x squared minus parentheses 2 plus the square root of 3x plus fun. Minus 2 plus the square root of 3 times x. Just a second, guys. I can't see. So I just have to multiply this out, all right? So I've got x squared, and then I'll just plus x times minus 2 plus root 3. All right, and then minus 2 plus root 3 times x, and then minus 2 plus root 3 times minus 2 plus the square root of 3. And then I can just clean things up. So what I have here is x squared plus, looks like, well, this plus and that minus cancel, so I just get minus 4x, I think, right? Phew, goodness. And when we multiply this, how does this multiply out? This multiplies out to give me minus 4, minus 2 root 3, plus 2 root 3, plus the square root of 3 squared, also known as minus 3. So I guess that's it. Let me check my answer right quick.
So I got the answer wrong.
Well, maybe, but I can't talk about wrong answers here right now. So, yeah, that's what I have in my answer. So, excuse me, this means then that B is minus 4 and C is minus 3, actually.
I've completely screwed up my missions.
You probably made a simple mistake, Michael. It's okay. So we must go on. 25C here.
So can you move the due date for the mission?
No, the mission's due today.
Then I'm going to fail.
I don't think that's true, Michael. You're not going to fail, buddy.
We can still change your answer.
You can change your answer still. Yeah. Here. Something that.
It's all my fault.
No.
Oh.
So 25C. You guys had a question about 25C. I think was the next one. So there, you guys will have to tell me. It's 30x cubed. What is it?
30x cubed minus 31x squared.
Uh-huh.
Plus 10x minus 1.
All right. And you're given information. So this is f of x, right? And I tell you f of something is 0, something of something else is 0, f of something else is 0. What did I tell you? 1/2, 1/2, 1/3, and 1/5. So I can do 30. See, the factor theorem tells me factors, right? So the factor theorem tells me that there's an x minus 1/2 in here. And an x minus 1/3 here. And an x minus 1/5. So that's how to do it. Now, I guess the one question you might have is, how did I know to put a 30 out front? Do you guys see why that is? Because that's the leading coefficient here. So if I multiply that out, I must get back to 30x cubed. That's why I just pulled the 30 out. Now, if you want to make that answer look prettier, what could you do? You could take this 30, right? And you could write it as what? 2 times 3 times 5, right? And if you multiply the 2 into this factor, the 3 into that factor, and the 5 into this factor, this could also be written as 2x minus 1, 3x minus 1, 5x minus 1.
That is a lot prettier looking.
So, but either of those are legitimate answers, all right? Either way is fine. You guys also asked me about number 31. Let me talk about that one. So number 31, we're supposed to decide if it's a hyperbola, an ellipse, a circle, a point, or nothing. So which part of 31 did you guys want me to look at? A, B, C, or D? All of them? I think I'm going to need you guys to pick a part. Which one? B? Part B? Well, let me pick the one that's like a little bit tricky. I'll start with A. A is slightly tricky. We've got x squared plus 2x minus y squared plus 4y equals to what? 0.
Professor Cook.
Yeah.
So, so for 30 times
Yeah.
x minus a half x, can I leave this as an answer, or do I
Yeah.
have to
Oh, yes.
simplify it?
No, this is a good answer. This is a fine answer right here. You can leave it like that.
Whew, thank you.
Could you please sit down?
I'm disrupting the whole
All right, so the problem with this one is completing the square is a little bit tricky because of that minus, right? So the instructions say to complete the square on both terms. So what we do is, before I even do that, I'm going to factor that minus out. So minus parentheses y squared minus 4y equals to 0, okay? Now that I've done that, I can complete the square in both x and y. So completing the square in x, we have x plus 1 squared minus 1. And then in y, I have y minus 2 squared minus 4. All of that's equal to 0. So when I excuse me, finish the algebra here, I have x plus 1 squared minus y minus 2 squared equals to, well, I have 4 minus 1, which is 3, so I think when I put it to the other side, I get minus 3. So then the question is this the equation of a circle, an ellipse, or an hyperbola, a point? I didn't talk to you guys about a point or nothing, did I, yes, last time? What's the equation of a point? I'll give you a simple one. How about this? What if I have like x minus 1 squared plus y plus 4 squared equals to 0? What's the solution set to that? The only way to get that equation to be solved is to put x equals to 1 and to put y equals to minus 4, right? So that kind of thing only has a 1 comma minus 4. So this is the equation of a point. All right. What's an equation like this that's got nothing? There's lots of them. But here's one. If I had like minus x squared plus 10 minus 10y squared equals to 6. If I had something like that, the solution's nothing, because there's no possible way you can have a sum of negative things. It's all negative, right? Equal to a positive. Like you can't. There's no such solution. So the solution to this would be nothing. Or maybe it's better if I write it this way: x squared plus 10y squared equals to minus 6. That's kind of more the way I usually think about it. The sum of positive things can't be equal to a negative thing, all right? Yes, sir?
Am I crazy, or would that negative 3 be not negative 3, but positive 5, or I just thinking that through?
Well, minus a minus gives me plus 4.
Okay.
4 minus 1 is 3, but then I have to move it to the other side. I move it to the other side, so it was plus 3 on this side, and then move it to the other side, it's minus 3. Yeah.
Can't you simplify that answer more by dividing it by negative 3?
Sure, but it's already obvious that it's a hyperbola. But sure, you could do that. It would be you know, x plus 1 squared
I didn't.
over minus 3 plus y minus 2 squared over 3 equals to 1. You could do that.
That's what I did. I just didn't know if you was.
No, that's also fine. That's fine. That's fine. Surely. I'm mostly interested that you complete the square and you identify which kind it is. That's all, okay? I didn't ask you to put it into a standard form of the equation or anything like that. Let me work another one of these that's kind of tricky. I mean, it's not super tricky, but I want to work another one where, yes? For which one? For A? No, the answer for A is hyperbola. Because it's not just minus, it's plus, it's a difference. It's a plus minus. When we have a difference of squares equal to a constant, that's a hyperbola.
Sorry if I got a little stressed out.
It's okay.
It's
We'll get
just
it.
I want to be perfect.
Hey, me too. Let's see here. Where was I? I think part D is also good to look at. So 31D. So I didn't put the answer, but this is hyperbola. All right. Part D, you guys will have to help me out. 2x squared plus 4x.
Plus 9y squared minus 18y.
Minus 18y equals to 0. Okay, so if I'm completing the square, the first thing I do, yes, Michael? Uh-huh.
Can you count x plus 1 square minus y minus square plus minus equals -3 as an answer?
Yeah, that's a hyperbola. I think that's the same thing. Yep.
Thank you.
Uh-huh.
Just wanted to make sure I'm prepared.
Okay. So we factor 2 out to get the x squared isolated. We factor the 9 out to get the y squared isolated, right? And now I can complete the square, right? So 2x plus 1 squared minus 1 plus 9 times y minus 1 squared minus 1. And I'll make one more step here. So this is 2 times x plus 1 squared minus 2 plus 9 times y minus 1 squared minus 9 equals to 0. Let me do one more step. So 2 times x plus 1 squared plus 9 times y minus 1 squared equals to, looks like 11. Did you guys get that too? So my question then is, what is it? If we have a sum of squares, a sum of squares equals to a constant, right? But they're not the same weight, not the same numbers on each square, then what this is an ellipse. So this is actually an ellipse centered at -1, 1. And we could figure out the radii, but I didn't ask you about that, so yeah. Now somebody had a question about, what was it I've forgotten? Who asked? 21? So I'll go back to that. Come on, computer. What is my computer doing? Well, that's interesting. Something has frozen my computer. It appears to be Chrome. Chrome, I'm going to kill you now. I said end task. Ha! Take that, Chrome. $21?
Yeah.
Yes, Holly?
What's going on in 31D?
What's go?
Okay.
Because, can I explain to you?
Sure.
Okay. So you see how the 2 plus 9 is equal to
Did I ever move the camera? I do think there's a slightly easier way to do the first problem I did today, but the way I did it's okay. It's just, I think there's a slightly easier way to do it. But anyway, so problem 21, Santa's cost of manufacturing fully automatic BB guns is given by C of x is equal to 30 x minus 4 squared plus 100. All right. And then the question is, I say x is the hourly wage of elves in Bitcoin, of course, and C of x is in American dollars. Then what is the minimum cost to assemble the BB guns? So how does that, why is that problem even meaningful? Well, if we look at the graph, right, of cost versus x, what's it look like? What's the vertex of this parabola? Right? This is, if we put this equal to y, think about that as being y. Yeah, I saw somebody going like this. Where's the vertex? I can look at it. It's at where? 4 and 100. So the vertex is at 4, 100, which I can kind of roughly graph as here. All right? And so I mean.
Bless you.
So there you go. There's the cost function. So can you guys understand the question then? How do we understand what's the minimum cost? Where does the minimum? Yes, Michael.
The minimum cost is $100.
That is correct. Why is that? It's because that point right there, right? It's 4, 100. So that tells me minimum cost equals 100. So all of the questions I ask you guys in here about minimums or maximums, the idea of every single one of these questions that I can come up with, it's always just the equation describing what you're looking at is a parabola. So the minimum or the maximum of the thing you're looking at is either, it's the vertex of the parabola. So you just find the vertex that gives you the min or max. Which of course you could use the minus b over 2a formula to figure out where the vertex is if you wanted to. But anyway. Other questions?
Can you do the 32?
32. I think this will be the last question, then I'm going to have to collect them.
Oh, hold on.
I'm not erasing anything.
Let me fix my mistakes.
Problem 32, we have x squared plus y squared equals to 4. And what else do we have?
P32.
Yeah, problem 32. X plus y equals to 2. All right, so let's make a graph of what we're doing, and then we'll do the algebra. All right, so what's a graph? The second equation is y is equal to 2 minus x. The first equation is a circle of radius 2 centered at the origin. So graphically what we're up against here, I'll draw it over here, is this circle, right? The radius is 2. And then we got this line, y equals 2 minus x. What's the graph of that look? What's a line? What's its y-intercept?
0. Oh, radius y-intercept? Yeah, that'd be 2.
The y-intercept of the line is 2, right?
Yeah.
And it's got a slope of minus 1. So what happens when we put y equal to, well, the x-intercept of this line is also 2, right? So it actually, if you really believe the graph, we've already solved it. But let's do the algebra. Let's work out the algebra. How do you do this? substitute, right. So we take this and we plug it into first equation, right? That gives us x squared plus 2 minus x quantity squared equals to 4. Do you guys understand what I did? Okay. And then what? Then we should FOIL it out, right? So we've got x squared plus 4 minus 4x plus x squared equals to 4. So we can cancel 4 from both sides. And what are we left with? Well, we've got 2x squared minus 4x equals to 0, which we could write as 2x times x minus 2 equals to 0. Lo and behold, the solutions are x equals to 0 or x equals to 2, which if I use my other equation, what is the coordinates? So we either get 0, 2 or 2, 0. And those are the points of intersection for the two graphs, which are the solutions to these equations. So make sure your name is on there and gather together your work and I'll collect them. There's a stapler here somewhere if somebody needs it. So.
Stapler, yeah. Oh, sorry. Sorry.
Thank you, Michael.
You're welcome.
I'm sorry. No violence. It's not the easy way. Exactly. It's not the easy way.
Thank you. Well, oh well.
Oh, it was. It was.
From 17 to 23.
All right, let's turn them in. Thank you. All right, guys, hand them over. Hand them this way. Hand them this way. Make sure your name is on there. That's the one thing I can't do for you, for sure. Yeah. Thank you. Thank you. Thank you.
Excuse me. Is this the answer?
Maybe. I really can't say right now, Michael. Do I have everybody's? All right, so next time there is a mission due, I will be collecting it at the start of class, which means you need to plan ahead to ask questions about the mission. I'll staple it. It's all good. Where's my stapler?
I passed it somewhere down there.
My stapler. Where's my stapler? I need my stapler. Please, if I could have my stapler. Thank you. So anyway, we got a little bit behind material-wise, which is why I did this today. But usually, my intention is to just collect the mission on this day at the start of class and then talk about the solution. Because as you have experienced, this is a little bit chaotic. All right, so now you guys know what the mission is. So when mission 2 comes around, you will have been working on it like before the week it's due, right? Yeah. So you've experienced that trying to finish the mission in the week it's due is suboptimal.
I started mine on the first day of class.
He will be in the hallway for his beating afterwards. See here. Yeah. So, this solution should be posted in Canvas, if not already, soon. If by the end of tonight it's not there, email me because something went wrong. All right? So the test, what's on the test? Well, the test is, it certainly covers, how to solve two equations and two unknowns. I don't always even test this first problem because this is really prerequisite material.
Test. How many questions are there in solving two unknowns?
There are enough questions. I don't say exactly how many of each type of question, though. So we could have a question about like parallel lines, perpendicular lines, so you need to know about that, right? Finding perpendicular lines, we need to know. So I meant to make an announcement about this. From one perspective, I've left off a piece of information here, right? Because in order for there to be a unique answer, I would have needed to give you a point, right? So since there's no point, there's actually like infinitely many answers here. I try not to do that kind of thing in this class. That's just kind of an oversight there. So here, find the line through these 2 points. So my method is I find the slope, and then I use point slope. Make sure you know about point slope. Point slope is an important idea that you might not have seen before this class, right? Horizontal and vertical lines are...
Oh, should I write in point slope form for this one?
It doesn't have to be. It could be its slope intercept. That's just a way. This problem is probably the trickiest problem we've worked in this class, right? Find the closest point on that line to 4, 5. So the idea here is to look at the perpendicular line, because the intersection of the perpendicular line gives you the closest point. So I find a perpendicular line that goes through 4, 5. By taking the slope, which is 3, and converting it to minus 1/3, that's the perpendicular slope, right? And then I look for where those two lines intersect to find the closest point, which is to solve both equations at once. So I set y equals to y, and work it out. But again, this solution will be posted, so don't fret the details at the moment. Solving inequalities, if it's just one variable and it's linear, then we can just do steps like this, right? But more recently, we've been solving nonlinear inequalities. Can you just do steps like this to solve it? No, you cannot. You must use the number line method, right? So let's get ahead. Let's skip ahead to that. Although before I get there, we also solved absolute value inequalities. Yep. You can have a page of notes, so it can have formulas, it can have examples. Like it's totally fine for you to have a complete example of how to solve the inequalities. Totally allowed. And like I also said, a picture of your beloved, or like Elizabeth in poetry, if that's what floats your boat. Actually, no poetry. What?
I'm rolling with a poster.
Like so. A usual printer page size is the size that is allowed. And you can only write on two sides of the paper. Yes. Yeah, just front and back though, not in the middle. I once upon a time had a physics student. They were allowed 3x5 cards.
Is problem 7?
And they took the 3x5 card and they peeled it apart in the middle and wrote on the inside. That is not allowed in here as well.
Is problem 7 on the quiz?
Michael's asking if, I'm going to change Michael's question. Could a problem like problem 7 be on the test?
So,
Absolutely.
So all the problems.
These are all potential test questions, yes. Yeah. Will every one of these problems be on the test? No. Because the test is, you're going to do the test in 50 minutes, right? So, enough. Let's see here. So this one here, this is one I will tell you this. I would not ask you to graph y equals absolute value x minus 2 on the test. That will not be on the test, I will tell you that. Graphing absolute value function, that's like a test 2 thing. So this one kind of is a future problem. So sorry to make you time travel, but that one we'll wait for later. Now,
what is...
but parts C and D here are good questions for the test, like solve absolute value of x minus 2 less than 1, or solve absolute value of x minus 2 greater than 1. These are certainly potential test questions. Remember, if you have the less than, we unwrap it with, remember, less than 1, we put minus 1 over here and 1 over here and solve, okay? But greater than 1, we have to solve them separately. A lot of you guys are pretty confused about this on the quiz, so you need to work on that. Yep. You must write the answer in interval notation, if I ask for interval notation.
Format again.
What format?
The quiz. The test.
Well, we're talking about it right now.
No, I missed parts.
I'm not sure what you mean, Michael, but...
You can just watch it on YouTube.
But I have work to do.
So this one here is an absolute value greater than problem. So that means I have to either do less than minus 8 or greater than 8 here. So then I have to solve these two problems separately, right? I either have x is less than minus 11 halves or x is greater than 5 halves. So the solution set is the union of these two big sets, right? Yeah.
I just treated it like negative and then swapped at the end and got the same answer. That's still like...
Oh, that, if you explain yourself, that's fine. Yep, yep. I like that method. So let me skip ahead here because there's... I'm going to skip ahead a bit here. So in these problems, problem 28, right? We cannot solve these just by, if your solution doesn't have a number line, you're wrong. It's just as simple as that. You must write the number line with the pluses and minuses for credit. Okay? Do we understand? You must write the number line with pluses and minuses for credit. If you do not write the pluses and minuses with number line, and you have the right answer, I will still take points off. I want you to understand, you must learn this method. Every test, I have about 40–50% of you guys try to do it without that, and about 80% of those people get it all wrong. So we must use the number line method, okay? So here's one. To do the number line method, you have to understand how to factor this. So I factored it.
Oh, let me correct my answers.
And then, don't worry about it, Michael. So this is minus 4, minus 3, and 3. I plug in points in each region, and then I can answer the question. See, greater than 0, I'm looking for pluses, which gives me minus 4 to minus 3, and 3 to infinity, like that. Do you guys have any questions about these particular method, or, yeah?
I just had a question in particular. Now, you said some things that were on the mission wouldn't be on the exam, but is it like vice versa? Are there things that weren't on the mission that would be on the exam?
I think the mission is pretty comprehensive as to what would be on the exam.
Right.
Because I have had, we had back here, we had, factoring, of course, is a big thing. Like, factoring is a big part of the test. Yeah? Trying to go back to the factoring here. Graphing parabolas. We should probably talk about this for a minute. So, a lot of you are still confused about factoring versus solving. Factoring means that your answer is an expression. It has x's in it. All right? If the problem doesn't come to you with an equation, which is the stuff with x equal to 0, or stuff with x equal to another thing with x, that is, that's an equation. This is not an equation. This is just an expression. So what you do to an expression, one of the things you can do is factor it. That's what we do here. So factoring, the answer is a factored form of the expression. All right? And likewise for this problem, I'm factoring. Solving is a very different thing. It's looking for the x's which, when we plug it into an equation, work. So these are all factoring. Solving would be like problem 18. Notice I have inequality here. That when I have an equality, it's a solution, it's a solving problem. And so there, I try to isolate the square, take the, I find solutions. My solutions are x equal to numbers. For factoring, the solution is the factored form. These are different problems. You must understand the difference between these two things. A lot of you don't. Now graphing.
Oh wait.
Graphing a parabola, the main thing we learned was there's a vertex, right? You can find the vertex. If it's in vertex form, you can just read the vertex off. Like the vertex for this one is 3, 5. Right? This one, it's not in vertex form, but if I complete the square, I can see that the vertex is at -3, -16. So that was another big thing we learned. The other thing I haven't talked about yet.
I wasn't focused.
It's okay. You can watch this video later, right?
But I disturbed the video.
Not at all. Let's see here. So, ooh, cat hits lava. That sounds good. What? Where else are you going to put the cat? No?
In the water?
What do you guys want? Like a wood chipper or something? I mean, what do you want from me? Sorry, that was wrong. That was too far. It's too far.
What's the cat ever do to you?
I like children in my home kind of person. So the other thing I would say is like solving polynomial equations. If it's factored, you can solve it, right? If it's something equal to something else, then you need to make it become equals to 0 and then factor it, right? This one is kind of sneaky. It's actually a factored by grouping problem. So we brought it to the other side like that, and then put the minus through here, and then you can see that you have a common x squared plus 3x minus 4, which then allowed me to see those solutions. So there are problems like that. But again, how do I know that this is not a factoring problem, like just a factoring problem, is because this is an equation. So equations, you're looking for solutions. So pay attention to the instructions. If I say factor, you should be factoring. If I say solving, you should be solving. Now, is factoring part of solving?
Yes.
Usually, yes. But beware. All right. I will post the solution to quiz 3 when I get a chance. I have it, but I just haven't posted it yet. So sorry about that. Thanks, guys. Let me turn off the camera here before I forget.
Thank you.